Welcome. In this video, we're going to be discussing how to calculate standard deviation for ungrouped data in a frequency table. Now, you could use any of the formulae that we talked about previously, but sometimes the question restricts the formula. For example, we have a question where we have the ages of 40 students. That's the age and then the frequency. And we're required to find the standard deviation, but specifically using this formula. So depending on the formula, we get to calculate specific things. So in this case, in all cases, we need to first calculate the mean. So we know that the mean, which is x bar, is going to be summation fx over summation f. Now from our data, this is our x and this is our f. So meaning that I am going to go on multiplying the individual columns. So this is going to be 3 times 14 plus 15 times 24 plus 16 times 11 plus 17 times 2, and everything divided by the summation of frequency, 3 plus 24 plus 11 plus 2. Or you could just get it from the question because it does say 40 students. So from the calculator, we have 612 divided by 40, which is 15.3 years. Now that's our mean. So our standard deviation, because they did give us the formula, becomes the square root, make it bigger, the square root of f of x minus x bar. So this is going to be 3 for the column of for the column of frequency of age 14. So that's 3 times 14 minus 15.3 squared. So 14 minus 15.3 squared. So this is the f, this is the x minus x bar, which is the mean. Then plus, I proceed to the other columns. So this is 24 into 15 minus 15.3 squared plus 11 into 16 minus 15.3 brackets squared plus 2 into 17 minus 15.3 brackets squared. Now everything over our n, or summation f. And because we already know it, we don't need to put it to add again. So that's our 40. Now from my calculator, this is 18.4 divided by 40 under square root. And this is going to be 0.678 years. Now this is the standard deviation. Now there is another way of doing it. If the data is really huge, like the number of columns or the ages were more than that, let's say 14 to 25, I would recommend drawing a table. So though if the data is small, you can work it out straight away. Drawing a table would mean that we have age in years. This would basically be our x. I have my frequency f. I would add on a column for x minus x bar. I could square it at once, and then I would add on another column of f into x minus x bar squared. Now the totals that I need, so that's I compute all those values, I would have summation f, and I would also have summation of f into x minus x bar squared. That is the values that you got here, and you total them up at the bottom. So if I have big data, I need to, columns would be faster because you've organized the data and it's easier to see, and then your standard deviation would straight away be summation of f x minus x bar squared. That's basically the total there, over summation of f, and then that is the square root.